Hi, everyone. I'm not sure if people can hear me yet. Okay, I think we're going to get started because I'm not sure if... Oh, thank you, Atif. So let's be on time. So welcome to this session. Thanks a lot for joining today. My name is Vijay, and I work as the head of data engineering for Soda Data. So today I'm going to walk you through about some of the ideas behind the DataOps, the principles, the core principles, and also a bit of practical guidelines on how you actually apply those principles in your data projects. So that's the topic of the section. And we have essentially three different points that I'm going to walk you through. One is the core principles. Well, I mean, DataOps has been a kind of a new wave thingy, which is based on the DevOps ideas a little bit. But we kind of try to summarize it into 6 different principles that we think, based on our experience, based on my experience as well as a data engineer, as well as the head of the data and analytics side. So we try to distill that into some core principles, and I'll walk you through those things. So some of them probably resonate with you, and some of them might be hopefully new to you as well. And after that, I'll also give some practical examples of how you actually put these things into practice. And finally, since I work for Soda, spoiler alert, I'm going to talk a little bit briefly about one of the pretty awesome open source tool that we recently released that we think is going to help you a lot in building your DataOps stack. So what is DataOps? Obviously, you're at a DataOps conference, so most of you are aware of it. So in my opinion, at least, this is what I think when I think about DataOps. It's a process framework that helps the data teams deliver really high quality data and reliable data insights with high velocity. So it's not just about the delivering insights with a fast, super fast data insights, but also the issue is that you want to make sure that people actually trust your data that you're delivering and the quality as well. So obviously the word is pretty much similar to what you have heard in the software engineering domain a lot. It's called DevOps. So DataOps is inspired from DevOps and also agile principles, and then applies them to data analytics as well. So what are the core principles that we want to talk about, that I want to talk about today, are basically these 6 top items. One is that implement the best practices for the development. The main reason why I think it's a core principle is because the data domain, if you talk about data engineering, data analytics, or data scientists, they are coming from different sorts of backgrounds. So not just from software engineering background, but also from different sorts of backgrounds. And data engineering and the data science is code heavy. That means you want to use some best practices that are kind of lessons learned, if you will, from software development or software engineering. So you want to follow the SDLC, which is basically software development lifecycle guidelines, and implement that into your data engineering projects and data operations projects, analytics projects. And continuous delivery, which is kind of a cornerstone of software engineering these days. One of the fundamental things for DevOps. That means you need to automate and orchestrate everything. So you need to make sure that the data is delivered from code all the way to the deployment. So you need to orchestrate as well, not just automating them, but also scheduling them. So there is a second core principle that we think it's a very important when you're creating a data analytics project. And then continuous integration. So this is something that all these the top 3 things must be fairly familiar to the people who are coming from the software engineering background, because there we write tests, test-driven development. We have testing at every stage. We have unit tests, we have integration tests, and completely automated as well as part of your pipeline, which is the main idea behind the continuous integration. And we want to apply the similar kind of ideas into testing the data quality as well, because the data analytics projects or data projects are the main core of it is the data itself. So you want to validate the data at different stages of your entire data lifecycle. Your data is flowing from A to all the way to Z. And then improve the observability. So in normal software engineering and in the world where you deploy products, you have sort of a system metrics, and then you improve the system by monitoring different kinds of metrics, performance metrics, etc. But you also want to have the similar quality metrics and performance metrics across your data flows. So to achieve proper SLAs, etc. And then you need to focus on the data semantics. So this is something that's kind of a struggle for many organizations, and even in my experience as well, in several smaller startups to all the way to bigger companies like multi-million-dollar banks, etc. Having a common data model, common metadata model helps a lot in driving the data ops and delivering the value quickly. And finally, a cross-functional team. So you can deliver all this data, and then you convert that into information, but that needs to be consumed by humans at the end of the business, and then increase the collaboration among the stakeholders. So how do we apply these principles in practice? So I'll go through one by one. So the first one, as I talked about, is implement best practices for development. So what we mean by best practices is maybe first for the people who are coming from business analyst background and then jumping into data engineering side or data ops side, people who are directly learning data sciencey stuff, spend time on that one, but have never gone through a project or that is building products using normal software guidelines. These things might be a bit strange to you, but if you are from that domain, these things should look pretty familiar. But the idea here is that you want to apply all these techniques or the guidelines that you have in your software development lifecycle. You really want to apply them to your data projects, so that will improve the quality of your code. So, for example, version controlling, I'm pretty sure everybody uses Git or GitHub these days. And then code reviews. So your code must be reviewed by everybody. So make sure that you're following some sort of a PR flow. And then unit testing. So you do write a lot of code, like in your pipelines, in your data transformation tools, everything. So you want to have a technology that you can unit test easily. So obviously you don't want to do the translation using Excel, data transformation using Excel. I mean, no judgment. It becomes very difficult to create tests for those kind of functionalities. So make sure that you use a tool that is amenable or easier to unit test. And then artifacts management. So this is something that has been followed a lot in software development. So you deliver artifacts with a specific release control, release automation, etc. So one of the ways is delivering a Docker image, for example, and then release automation. So you really don't want to have like a script, that script to deploy your data projects or data artifacts. So you want to have a continuous delivery using a release automation pipeline. And infrastructure as a code. This is a very critical thing as well. So the code is kind of ever pervasive thing. So initially it was just software, and then now we are making all the infrastructure details, like including creating virtual machines or what have you, and then networking and everything. So one prime example of this is using Terraform, for example. So you can create your infrastructure using code. That means you can maintain the infrastructure versions, and then you can follow the track of the entire flow of you can follow the changes to infrastructure pretty easily, just like code. So a few of the tools here that you might be familiar, or if not, you need to really use them. Something like GitHub or GitLab to collaborate, and Terraform, Ansible, which is a configuration software that you can use to configure different servers infrastructure, and the Docker, or something like an deployment platform or artifact delivery platform. And then the second one that we talked about is automating, orchestrating all data pipelines. You really want to automate this using some sort of a continuous delivery pipeline, and you want to discourage any kind of manual data wrangling. There is always going to be somebody, I'm pretty sure, in your companies or in your organization, in your department, saying, okay, let me just create this table for some time, and then we'll figure stuff later, how the data is getting into this one. These things become a liability later. So you really want to discourage any kind of